Alright guys, before you start this video, just make sure you saw the first two videos, which helps introduce the concept of projectile motion and introduces you to basically how we're going to be solving these problems using some of the skills that we already have. So again, there are two parts to that. There's two videos, two separate links. This is part 3. At this point, again, I will be going through some actual examples from our assignment. And again, our assignment will be to finish this worksheet, so I'm basically starting it for you, showing you, what some of the questions will look like, and we'll go from there. Okay, so again, like I said, when I start this, it is assumed that you've already seen the other two videos, so I'm not going to introduce projectile motion to you from scratch. So the first one that I have here, and it has a little sketch up on the top, we got a soccer ball. It's kicked from the ground with an initial upward velocity of 90 feet per second. And again, remember that upward velocity is going to be that constant next to your linear term. That is that initial upward motion. And remember, this negative 16 is going to represent that force of gravity in feet per second pushing back down on that object. So that's why it does not just go up forever. So that's why that object again has that parabolic path to it. As you can see, it starts going up, but again, that force of gravity keeps pushing against it, and it eventually slows down and starts heading back to the ground. So at this point, we have an equation. It's a quadratic equation, as you can see. And you want to make sure you recognize the x and the y values. In this case, the x values is our t value, which represents your seconds, how long it's been in the air. And h is your height, so how high up it is in the air. So the first question we have is how many seconds will it take for the ball to reach its maximum height? So if you're looking at this graph, and this is a graph of that function, remember this is a function of height over time. So t is your input, whereas h is your output. And we want to know this point right here, but not just that point. We want to know how many seconds will it take to reach that maximum point. So again, this is our maximum value, which is an xy value, and actually I don't want to call it xy, which is a th value. And again, we want to know at what time did we reach our maximum height. So if you think about the concepts that we've learned up to this point, here's what we're going to have. I want the input of the vertex. Again, I want that maximum point, but I want the x value, which means I want the input of the vertex, which is the axis of symmetry. We are going to be doing, in this case, the axis of symmetry, which is x equals opposite b over 2a. Again, that's going to give us our t value, our x, which is our input value, like our x value, our input at the vertex. So again, that's this point right up here. Okay, so in order to do that, we're going to go opposite b, which is negative 90, divided by 2a, so 2 times negative 16. And we just have to do a little bit of simplifying, but it's going to be negative 90. And a lot of the numbers in this problem, in all these problems aren't going to work out very nice. So just be aware of that, because these are applications. They don't work out pretty. So I'm just going to go 90 divided by 32, which is going to be approximately, well, actually I can bring it all the way out here. It's going to be 2.8125. Now remember, this is the x value of the vertex. So this is a t value in this case. So it's going to be about 2.8125 seconds. And again, that's the time that it takes to reach its maximum height. Now the second part, part B to this, is what is the maximum height. So again, we're looking back at this point. So I'm going to go right back up here real quick. So I found t. I found it. So I've got that done, and now I want to know what is the actual maximum height. So now I'm going to find the y value of the vertex, which in this case is h. So I'm going to come up here, I'm going to go ahead and find that y value, and the way you do that, you just find, in this problem in particular, h of 2.8125. So when I plug all this in, I'm going to get negative 16 times 2.8125 squared plus 90 times 2.8125. So again, I'm plugging that input value of my vertex into the function to get the y value, or the output of my vertex. So when I do this, I'll go ahead and show this one actually on, let me get this up here, I'm going to show this on the calculator so you can see what I'm doing here. So this is going to be negative 16 times 2.8125, and then I'm using the parentheses. I'm going to hit that square button on my left hand side of my calculator. It says x squared on it, plus 90 parentheses 2.8125. So I plug all this in and it gives me my height, which is about 126.5625, and you can round that to 126.6. That's obviously perfectly fine. So I'm going to move that out of the way. So I had about 125.6 feet as my height at that point. Now once you do all this, they want the domain and range. So now when you get to domain and you get to range, again, the domain is normally going to be all real numbers, but we have an application now, and that application, now I'm going to come back up here, is relevant to the picture. So my domain is only going to be during this path, because once it hits the ground, my function is done. I don't have any more of that function. So if you want to figure out the domain, you have the starting point of the domain. You have this point right here. See what I'm doing right there? That's 0. I know the domain starts at 0 because when time was 0, I'm good. So my domain is going to equal 0 to some number, and that number is a definite number. And if you don't know what that number is, well, I'm going to come back to that picture and show it to you. So that number is going to end up being the point where this touches the ground. So that point is going to be t, 0. So I need to figure out where that point is located. So I'm going to do that by using some of my solving techniques. So in this case we have t0. I need to solve for it to get my domain. So here I go. I'm going to take my function and I'm going to take my height, and I want to find my height when it's equal to 0. So in order to find the rest of this domain, we need to find the 0 of this function. So I'm going to go 0 equals negative 16 t squared plus 90t. Okay. So in order to do this one, and there's always different methods of solving this, and that's one of the things we will be approaching this week, is you have options now. You can solve this any way you want. Now this one does have a calculator that you can use, so I will kind of show you a couple of these as we go through. But again, one option is to solve it with your calculator. Now it's kind of hard to show that here because my calculator looks a little different than yours. I don't want to overly confuse you. I will show you how you can solve this by factoring. So I'll give you that method this time. And again, it helps. Again, we have a calculator we can do this with. But here's how I'm going to solve this using the factoring method. It's already set equal to 0, so it's set up. And I'm just going to go ahead and pull out a GCF. Actually, I don't want to put that right there. So my GCF, in this case, I'm going to pull out a negative 16t. I'm going to pull that out of both terms. You don't actually really need to pull out the 16 or the negative or any of that. I really only need to pull out the t, but you'll see it doesn't really matter. So I'm going to go 0 equals, I'm going to have negative 16t out front. And again, as I said, answers on these application problems don't typically work out to be pretty numbers, so don't freak out if you get a decimal here. So the first term we need to divide is just going to be t. That's me taking these two guys and just dividing them out. And then I'm going to go 90 divided by negative 16. And this is going to give me a weird number. I mean, I want to say super weird. It's a number. We can deal with it. But it's going to be t and then minus 5.625. Now, if you are able to factor this, and by the way, the 5.625 I did by taking these two numbers and dividing them, 90 and negative 16. So now when I solve this, I'm going to get negative 16t, and I'm going to get my second equation, which is t minus, well actually, let me go back and do this. Sorry, my first equation, what you're going to do is take your factors, you're going to set them both equal to 0. So negative 16t equals 0. And you're going to get t minus 5.625 equals 0. So when you solve both of these, you get t equals 0, and you get t equals 5.625. and I wrote that wrong. I'll fix it. There we go. Okay, 5.625. So you're going to get 5.625 for your second answer. Now, we're going to disregard the first one, and the reason why we're going to do that, we're looking for the later time, the time where it hit the ground. So I'm not concerned with any earlier times that I might have. So what I get is a 0, which is when this hits the ground, of 5.625. So I'm going to go back and solve this. I'm actually going to get a domain that starts at 0 and goes to 5.625. That's my input. Now, that's going to be your domain. Now, one thing I just noticed when I did all this is the graph that I did up above is more just a sample graph. It doesn't actually go with this question, because if you'll notice the difference between these two, I got a 0 at 0. Well, if you look at that picture, when I'm at t equals 0, I'm not on the ground, because that's not the graph that really represents this one. You'll see this one said the ball was kicked from the ground. So I'm going to show you what that picture looks like real quick so we can see it. All the properties are still really the same. It's just a slightly different starting point on my graph. And again, it was kicked from the ground. So our graph would start on the ground, and it would be a quadratic function that does this. And again, we have a couple points here that I'm just going to go ahead and label them all now. We have the point 0, 0. We found that point already. We have this point, which is at 5.6. I'll just say 5.6, comma 0. And that was my 0. That was what we used for our domain, actually. And we have a vertex, and we found that vertex already. That vertex is going to be at about 2.8 seconds. And the y value at that vertex was 125.6. So we have all these points now that we found on our graph, and again, if you think about it, these are all the points we've been finding anyway. That would be zeros and vertices. Those are your very important points on a graph, and that's really all we're doing. We're finding a vertex, we're finding a 0, and we have all these different methods that we can use to find it. So at this point, you can now find the range if you really think about it, because the range starts at 0. We don't go below ground here, where the soccer ball just hits the ground and stops. So my range, I'm able to go ahead and label, and my range is going to range from 0, which I do touch, and it goes all the way up to my vertex, which is at 125.6. And I think that in this case is feet, but again, we're all good anyway. So that's going to be your range. And again, we got our domain, we got our range, we have our vertex, which gives us the maximum height and the time it takes to get to that maximum height. So again, you can just label all those answers right off to the side. And again, that's what I'll be checking too. I mean, obviously I need to see your work when we go through this, but I also want to see the answers. So just go ahead and post those answers there. I mean, I figure you can do all that yourself. And I'm going to do one more for you here, and that's the last one I'll do for you, because it does have something that says it's a little bit different from the one we just did. Although, again, remember, a lot of what we're doing here is, again, finding vertices, finding zeros, and things like that. So this one, again, is a little different because of what it's asking. The equation itself isn't really much different. Again, you'll see a lot of this -16, because unless we're on Earth, that force of gravity is going to be the downward force on the object. So we can have any initial velocity we want. This one doesn't represent an initial velocity. You'll see that there's no t term. Like, where did it go? Well, it's 0t. That's what it is, and that's why you'll see in this problem we are not throwing this penny. We are dropping it. So it doesn't actually have a velocity. It just has an initial height. And that initial height is going to be 1250. Again, if you go back up to this first problem, you'll see that this did not have an initial height. It did not have a c value. C, where was it? Well, it's equal to 0 because the ball was on the ground. It was being kicked, though. It was being kicked with a force of that 90 feet per second. So that was that initial velocity. So as you go through all these, this is a little bit of physics review for you as well. You look at number 10. Again, we got our force of gravity. We have an initial velocity on this apple that's being launched. It's being launched at 64 feet per second. So it has, a left or right directional force In this case, we'll say to the right on our graph, and we had an initial height. So it was, we have all three going on there. Same thing when we get down here, and then I'll get to number 4. We'll just do it. But again, we have a 12-foot platform, so it's off the ground. We have an initial velocity of 128 feet per second, and we are on Earth. So again, that's what all these things mean. These numbers all have meanings. They're not random equations. So in this case, here's what we have, and I'll draw a picture of what's going on here. So we got our XY plane, and this is again an item being dropped. So we're going to be up here at 1,250. And again, this is going to be a graph that's just showing an object being dropped. So if you look at it, it actually makes this graph a lot easier, because here's what we have. We have a graph, and if you look at it, the vertex is already found. We already have it. We don't have to find the vertex because there's no force pushing it up. It's just being dropped. So we're starting at that maximum point. If I graph this to the left, it would look like that. Okay? So that's a really nice part about this one. So we have an equation, we have a graph that goes with that equation. Again, we already have the vertex, which is great. And I may have this point I need to find. You'll see in this case it's a little different. But if I ever asked you to find out when it hit the ground, we just set it equal to 0 and solve. And again, we'll get a plus or minus answer when we do solve it. But we're not asking to do that here. So here's what we can do. We want to know how long will it take the penny to strike a 6-foot tall person. So you got to understand on this problem, we have a 6-foot tall person. So I'm going to go ahead and put that in red here. And that person is not on the ground. He's standing up. How much is he standing up? Well, I would assume 6 feet off the ground. So we want to know when that object hits this point, not t equals 0, but I want to know when it hits t comma 6. I want to know when that height is equal to 6. Now you say, well, how would I do that? Well, if you don't know how to do that, look at your equation. This equation right here is equal to height. So instead of calling my height 0, I'm going to call it 6. So I'm going to go 6 equals -16 t squared plus 1,250. So you have now, again, you have an equation. Now, what I want to make sure I'm expressing, because this is what we're going to be dealing with as we go through this week, is just, and really as we get ready for our test, is we can really choose whatever method we want to choose to solve this equation. Now in this case, notice I only have one variable. That variable is t. I don't have a t, or I have that variable is t squared. I don't have a t squared and a t, so I can solve this just using general methods. It's called the square root method, and I can just solve this for t, which means I'm going to subtract 1250 from both sides. So when I do that, and I'm saving it all in the calculator anyway, although I can subtract that without it, but 6 minus 1250 is going to get you your -1244 equals -16t squared. And again, I'm just solving for t, so now I'm going to divide that by -16. And now we're going to get t squared equals 77.75. Remember, your answers aren't going to be pretty. It's okay. So now we square root. Now remember, when we square root, technically speaking, we have a plus or minus answer here. And when I do take the square root, that answer that we're going to get is going to be plus or minus 8.82 seconds. So approximately plus or minus 8.82 82 seconds. Now, because of this problem representing time, you're not going to hit a person on the head at -8.82 seconds. So we don't really we kind of rule out that negative answer. So it's going to take a positive, obviously, 8.82 seconds to hit that person that is 6 feet, sorry, off the ground. So that's going to be your answer for that one. So again, as you look at that, these are really all the things we can do. I mean, there's obviously different variations, but what you need to make sure you're understanding is that you understand there's all the different components of a function that we may have to find, which includes zeros, which includes the vertex. And again, I try to throw this in here. We can even find specific values. I may ask you, at what height were you at after 2 seconds? And that's what some of these questions will do. And again, if, for example, if I'm on number 2, I want the height after 3 seconds, plug in 3 right there. You know, those are kind of easy. That's why I kind of skipped that one. But this one's asking you the opposite. It's saying, okay, here's a y value. Go ahead, plug that y value in and solve for your x value. And that's what we did on number 4. So again, I can ask you for a specific x value, a specific y value, a 0, or a vertex. So these are all the different things we can find. We know how to do all of these. And again, when we do solve, remember we have all those methods at your disposal. If you want to solve these using the quadratic formula, you can. If you want to complete the square, you can. If you want to solve by using your graphing calculator, you can. So you have all these different methods. I just want you to get the answer. I don't care how you get there in this case. So if I ask you specifically in other problems, then great. So what I want you to do at this point, go ahead and finish this worksheet. This is your homework, so I started it for you. All you got to do is finish it all the way up through number 9.